Okay, like I said, I won't go through every single part, but if you turn to the summary, there are some things that are already covered in O-level, so I don't want to go through too much. Product rule, quotient rule, I think you should be quite familiar. Don't want to say too much. I want to focus on a few more things, okay? These are not in MF15, okay? Sorry. Not in MF15. Those that are in MF15 are already highlighted for you here. Here. Okay? So no need to memorize how to differentiate secant x. This one is already in MF15. Just take note. You must also be familiar that all this differentiation of inverse trigo functions are also given in MF15. No need to memorize. Alright? No need to memorize. Okay, I want to highlight this point. This one, if you take a look at part 4, derivative of log functions. There is actually this example here. If you see, how do you differentiate log to base 5 1 minus 3x squared? Do you know how to differentiate this? I want to add a note. If you know how to do change of base, if you can remember your O-level change of base, then actually there is no need to remember this at all. It's not necessary. Why do I say that? I give an example here, log to base 5. Okay? Log to base 5. How do we? If I don't remember this, I actually should know how to change my base to ln 1 minus 3x squared divided by ln 5. Correct? Should be able to do it, right? You can change your base to log to base e. Here to here is O-level stuff, change of base. Right? Change of base. After you change your base, what is 1 over ln 5? 1 over ln 5 is just a constant. Ln 5 is just a number. Then do you know how to differentiate? You can actually factorize 1 over ln 5 out. Do you know how to differentiate ln 1 minus 3x squared? You actually can. It is actually this. 1 over ln 5 is just a number times minus 6x over 1 minus 3x squared. This is applying chain rule. Here to here is applying chain rule. Differentiate this, you get this. 1 over ln 5 is just a factor, you just put it outside. Is that right? Okay? Now, then you ask, why still not the same as this? Actually, they are the same because this log to base 5e is actually 1 over ln 5. This is actually the same as this. These two are the same. You change your base and you will realize. Correct? Change your base and you realize. This is actually the same as this. These two are the same. This and this are exactly the same. So there you have it. So my point is this, you do not need to memorize this if you know how to do change of base. Okay? Alright, good. Got that? Okay. Okay? You know how to do change of base, you do not need to memorize that. Okay. And then I highlight this part. I just want to emphasize this. You must be very careful. Let me erase this one. I want all of us to know what is the difference between differentiating x cubed versus differentiating 3 to the power of x. Do we know the difference? I'm quite sure we all know how to differentiate x cubed. This one O-level stuff, I'm quite sure you know. It's quite easy. You get 3x squared. You bring the power down, etc. No problem. Now, the dangerous thing some of us may want to do is, I differentiate. I bring x down, 3x minus 1. Obviously wrong. Obviously wrong. Now, I want to emphasize this. The base is a constant. The base is a variable x. The power is a constant 3. Whereas this, the base is a constant 3. The power is a variable. So you must differentiate these two. as in make the difference, distinguish between these two. Distinguish between these two. So these two are clearly different. So this one is easy. Then you ask yourself, how do we do this? Of course, there's a formula. But I want to prove the formula to all of us. Then after that, you remember the formula if you want. If you don't want, also can. Let me show you this. Now, before that, do you all know that 3 is actually E ln 3? And in general, A is actually E ln A for any positive number A. Need to be convinced? Need me to prove? No need lah. Or you use calculator and you realize this will always be true. That means you change 3 to any number, you'll always be the same. Always the same. Press calculator and you will prove to yourself. Now, then, what is 3? 3 is now E ln 3. So I change this to E x ln 3. Correct? Because it is 3 to the power of x, so this to the power of x, so it's actually E x ln 3. So far so good? Okay. Then you ask, do we know how to differentiate this? Recall, differentiate E 2x is actually 2e2x, right? You use chain rule, right? Correct? Differentiate e2x, that means e to the power of 2x, you 2e2x. You must apply chain rule, you must have a 2 outside. So now, what is E? Ln 3 is just a number. So is it not difficult to say that apply chain rule, you will get a ln 3 outside, ex ln 3. Make sense? Now, then what is ex ln 3? Ex ln 3 was actually 3x. You change this to this. This is actually 3x. Then finally you get an answer. Sorry. You get an answer. 3x are this and these are the same, right? 3x times ln 3. So you have an extra factor ln 3. So if you indeed want to memorize, actually is this. In general, you differentiate a to the power of x, you get ax ln a. Right? Because differentiate 3 to the power of x, you have 3x ln 3. You get this. The one in red is the proof. The red part is the proof. Now, if you can easily prove it, I don't think there's a problem. You don't need to memorize. If you indeed want to memorize, then this is the one. I won't say you never learned before, like you haven't. Okay? Any problems? All good? Okay. I want to talk a little bit about parametric functions later, because this is the part that most of us have difficulty. I'm going to use question 3 as an example later, okay? But before that, I want to highlight a few things. 1, avoid converting from parametric form to Cartesian form. This one, 99 times out of 100, there is no need to convert. Okay? Unless the question asks you to do so. If the question asks you to convert, then you just convert. If they don't ask you to do so, you will work from the parametric form. I know it's uncomfortable, but after a while you will be fine. Because the moment you convert, sometimes you face difficulty converting. Alright? And the example is here. Oh, sorry, before I go on to parametric, I want to say a bit more about this. Now, this one, the power is a constant. This one, the power is, the base is a constant. What if I give you an additional question and say, find dy dx if x to the power of 3x plus 1 equals to y. Now you have an expression like that where the base is a variable, the power also variable. Then which one do you use? Which side do you use? You have a problem. You have a problem, right? You choose which one also wrong. Which one also wrong. Any idea? Don't know. Very good. Law on both sides. Excellent. Take law on both sides. Take law on both sides, do implicit differentiation. Once you take law on both sides, you can do implicit differentiation. Just write down. I'm not going to solve for you. The answer is not important actually. The technique is important. You take law on both sides and you just write down. Take law on both sides, then do implicit differentiation. Then you know what. Okay? But definitely not this, definitely not this. Because this is when the constant is in the power, this is when the constant is in the base. But this one is neither. Right? Take law on both sides and implicit differentiation. Don't need to do, just write down, will do. Alright. Then we talk about implicit differentiation. Chain rule, I want to say this. Chain rule is very often forgotten when doing implicit differentiation. Then there is one example here. Then many of us will say, hey, actually nothing wrong with this implicit differentiation. What is wrong? Let's look carefully, okay? Imagine you want to go from left-hand side to right-hand side. You're trying to differentiate this expression. You use product rule. You differentiate y, you get 1. Keep this, you get dy dx. Then keep y, you get this. Differentiate dy dx, you get dy dx squared. Actually, nothing wrong. What is wrong? You want to spot the mistake? What's the mistake? Would you have done the same thing? The y, Which y? There are many y's. Which one is the problem? The 1, yes. This is the problem. Because when you differentiate y, you do not get 1. You differentiate x, you get 1. Because you're going to differentiate with respect to x. You're actually differentiating with respect to x. So when you differentiate 1 y with respect to x, you do not get 1. You get dy dx. You get dy dx. You actually get this. You actually get dy dx. Okay? Be very careful, alright? Be very careful. Okay. Again, there's the point is stressed here, we seldom convert from parametric form. Okay, this one, enough is said, I don't want to say too much. Now, when evaluating the rate of change of a variable term, do not substitute the given value. What do I mean? Let's say you have a problem. A, example, equals to pi r squared. Then dr dt is 2 cm per second. Correct? Then you find dA dt. dt when r is 3. It's a very simple problem. Correct? It's a very simple problem. Now what I mean here is that when I attempt to find dA dr, correct? Because you know dA dt is dA dr times dr dt, right? When I evaluate dA dr, do I substitute r equals to 3 inside, then I differentiate, or differentiate first, then I substitute? Yeah, that's what I mean here. You must always differentiate first, then you substitute the value. Because if you substitute first, you will get a constant, you differentiate in 0 all the way, you know. But now you can see this very well. All of us can see this very well. But the moment I give you complicated looking expression with like A, B, K, blah, 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 then you get confused. Then you try to simplify things, you substitute 3 inside immediately. But don't. So what I mean is you do not substitute. So you differentiate first, before substituting r equals to 3. Or you differentiate first before substituting r equals to 3. That's what I mean here. Is that right? Okay. This one. To tell you very honestly, rate of change has not come out in the A levels for some time. It has always been maxima minima for the past 5 years, if I can dare say. For differentiation, calculus, application of differentiation, it has always been maxima minima for the past 5 years at least. But when it's maxima minima, can you please remember this step, which is to perform a first or the second derivative test to say that it is, to prove that it's a maximum point or minimum point. I will illustrate that in question 4. Okay, I will illustrate that in question 4. Later on, okay? Maclaurin series. Now, Maclaurin series, we must understand the concept. Okay lah, many of us do blindly lah, but never mind. But essentially, what are you trying to do? You look at your formula list now. If I look at our formula list, this is my Maclaurin's expansion. This is the mother expression. You are actually trying to change, let's say for example, ex, sine x, cosine x, etc. Express it in terms of a polynomial. So imagine you have any garbage expression, ex sine x squared times x cubed, whatever. You are able to use Maclaurin's expansion to change it into a polynomial. That's the basic idea. So the principle is that you want to convert this into a polynomial. This one is any expression. So what happened is, in the formula list, sorry, maybe I just show a formula list. They have done the hard work for all of us for 1, 2, 3, 4, 5 standard expressions. But actually you are able to prove all 5. The mother is here. You just apply the mother to the children. Okay? Then you're done. Then you can prove the children quite easily. Correct? Yes? So, yeah, these 5 are the result of your Maclaurin's mother expression out there. Okay? Later on, we will take a look at question 11 and see how we can apply that. Alright? Now, when angle is small and x cubed and higher power can be ignored, we can use these 3. The first 2 no need to memorize because it's in the formula list. It's the last one that is not in formula list. This one. Take note. Tangent x equals to x. This one is not in formula list. Question 11 will illustrate the use of that later. Okay? Okay, enough of all this binomial. No need lah, huh? Let's jump straight into the question. Question 3. Right, question 3. I know it's not a difficult question. Actually, it's not. I deliberately chose it because I wanted to bring across the idea of parametric equation. Let's take a look. Now, if I were to key in this into the GC, I can actually look at the curve, the shape of the curve. Let me show you. Where is it? Now, you must be very careful. So now, I do parametric. Alright. Then then I get a 2 minus 1 and t square minus 2. Now I get this curve. Now this is not the entire curve. I show you what is the real curve. The real curve looks like this. Oh, sorry. This is the entire curve. However, your GC, if you sketch on your GC, I'm sure you will see the same thing. You will get only half of it. Can you please be very careful when you sketch your graph, your parametric graph on your GC? The moment you press 2A on at the start of an exam, whether it's you or the person next to you will always get this standard setting such that your window setting, your T minimum is always 0, unless you change it. What does it mean? That means the GC only substitute T equals 0, T equals to 1, T equals to 1.1, 1.2, all the way until 6.28, which is too high. So unless you change it, you will never get the other half of it. Just take note of that. But what I do want to go through is this. Now, what do we actually mean? Actually, some of us very confused, don't know what is parametry. See, this one, let me illustrate. If I substitute t equals to 0, what do I get? I get x equals to minus 1, y equals to minus 2. What does it mean? That means I have a point, minus 1, minus 2. If I substitute t equals to 1, I'll get x equals to 1, y equals to minus 1. 1 minus 1 here. If I substitute 1.1, 1.2, 1.1, 1.2, then I get other points. I get 0.5, I get some point here, 0.4, da, da, da. The collection of all the points that I can substitute will form me the curve. Every single point on the parametric curve corresponds to a particular value of t. So that's all to it. There's nothing magical about parametric equation. It's just this. It's just t equals to 0 here, t equals to 1 here, then t equals to something here. Actually, I tell you the truth, actually the curve is not required in this question. I don't need to sketch the curve. I'm just trying to illustrate. Now, let's take a look at the question. The question asks, show that the equation of the normal to the curve at a point, parameter P, is given by this. That means parameter P means what? At this point, the parameter is 0. That means T takes on 0. At this point, the parameter is 1. T takes on 1. At some random point, there must be a point, at some point where T equals to P, the question wants us to find the equation of this normal. The question wants us to find the equation of this normal, where the perimeter takes on the value P. Now, what is the coordinate of this point? When T equals to 0, you substitute 0 here. When T equals to P, you just substitute P in, you get 2P minus 1, P squared minus 2. It all makes sense. It's not done randomly. It all makes sense. At this particular point, the perimeter takes on P is P, therefore the coordinate is P, like that. Some of us change without really understanding, but it is what has happened. You are supposed to find the equation of the normal. Surely, the equation of the normal must contain P. Must contain P. Of course, must have x and y. Then we do the normal thing. So now part of the solution is this. Since x is this, wait, I can find this one quite easy, most of us can do. dy dt is 2t. Therefore, dy dx is 2t over 2. You get t. Now then we try and make sense of this. dy dx is equals to t. Actually very simple to understand. That means when t equals to 0 here, I substitute 0, my dy dx is 0, just nice, gradient 0. When t equals to 1 at this point, the gradient is 1, the gradient like that is 1. When t equals to p, the gradient is p, the gradient of the tangent is p, the gradient of the normal is something else. So I just write at t equals to p, dy dx, which is the gradient of the tangent, is p. Therefore, gradient of normal is minus 1 over p. Right? Gradient of normal is 1 over p, minus 1 over p. Then you can get equation of normal. You use the y minus y1 equals to mx minus x1, right? So y minus y1 p squared minus 2 equals to 1 this x minus 2p minus 1. Dot, 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 you get answer. I don't want to focus too much on the simplification, but this is the rest are more important. This is quite easy. Once you get this stage, you will get answer. There's no problem at all. Yes? Sorry? Yes, of course you can. It's a bit long, it's a little bit longer. The question is, can you use y with mx plus c? Yes, you can. That means you say that m is minus 1 over p, c is something that you don't know. Then after you subsequently substitute this pair inside. It's actually the same method. It's actually the same method. There's no problem. Alright, second part. Give a reason why there are at most 3 normals which passes through a fixed point xy. Wow. Don't know how to do, some of us, but never mind, we try. What do we mean? Suppose I have a fixed point xy somewhere here, I don't know what. Now, what they're trying to say is, I could have one normal here. I could have another, this is normal. There's one normal, normal one. There could be another normal that passes through this one. They want you to show that there are at most only 3 such normals that can pass through any fixed point xy, no matter where it's xy. Follow what I'm saying? No matter where it's xy, there are only 3 possible normals that can pass through this particular point. We understand the context first, then we can solve the question. Now, you have already found the equation of the normal here. For this normal to pass through a fixed point xy, that means this, you substitute x into small x, y into small y, this equation should still stand. Should be left hand side equals to the right hand side. So, first line is very simple. First line is this. If the normal passes through xy, then this equation must hold true. Small x as big X, small y as big Y. So far, so good. Now, remember, at this point, your t must take on a parameter p1. I don't know what is p1. At this point, t must take on a parameter p2. Every point corresponds to a parameter p. What we are trying to say is this p1 and p2 must satisfy this equation. Am I right to say that? Right? For some point here, p1, p2, it must satisfy this equation. So our job is for a fixed point, a constant xy, how can we solve this? And you're not trying to solve, you're trying to show that there are at most 3 such values of p. And it's quite obvious why there are 3 only, or rather at most 3. Because it is a cubic equation. Correct? When you solve cubic, you cannot get 4 solutions. So the answer is very simple. The answer is just that it is a cubic equation. So there are at most 3. Then the next part of the question asks, now, find the equation of the normal that passes through the point 1, 1. So now xy is now 1, 1. That means big X equals to 1, big Y equals to 1. So you substitute big X equals to 1, big Y equals to 1, then you get a specific equation in P. You're supposed to solve that. How to solve a cubic equation? I'm sure you all just use your scientific calculator or GC, up to you. Correct? Now I want to caution all of us. You may not make this mistake in this particular question, but I just still want to warn us. Let's say you try and solve poly root finder like that, right? Now, if by mistake you choose this, that means instead of real you choose this by mistake, I don't know how, okay? Or in fact, sometimes you solve order 4. See? The moment you choose order 4 equation, they don't allow you to choose this. They only allow you to choose this one. Okay? Never mind. Let's say you do this. Then you do this. Then you get 1, 0, minus 1, and minus 1. Solve. Is it minus 1? Minus 1 and minus 2, sorry. Okay. Now, be very careful when you see this. Actually, there is only one root, 1.52. There's only one root. But you see this, you all know what is this? You know or not? Don't know. Complex number, very good. Because you go down, you scroll. This is an I. Can you see I? Don't be scared, okay? The moment you see the dot, 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 complex number. But in this case, you don't want complex number. In this case, you only want real roots. So, actually, I deliberately did it. Actually, when you choose real like that, you will not get anything. You will actually get, you only get this. Right? So, answer is very simple. $1.52. Done. Yep. What if you put x and y into the parametric equation? You have a big problem. Why? Look here. There's a question here. If you put x and y in the parametric equation, because x and y need not lie on the parametric, need not lie here. Yeah? Okay? So that's why the diagram, I drew the diagram here for you to see the problem. Okay? Okay, thanks. Okay, let's move on to question 4. Question 4. This is the type. Maxima, minima. Again, I say, for the past 5 years, it's always maxima, minima. First thing I want to say, can I appeal to all of us? Can you please continue the question even if you cannot show this expression? You have to please continue even if you cannot show this. That means you assume that you have shown, then you carry on and grab the 3 marks with both hands. They won't be so evil. I think usually it will be show, then after that you do. And don't spend too much time on 2 marks. 2 marks on average, you spend 3 minutes, that's it, finish. Anything more than 3 minutes is not efficient use of time. Alright, 3 minutes. 2 marks only. So how do we get the 2 marks? First, we need a diagram. It's made of two equilateral triangle and one rectangle in the middle. Correct? And this is length is S, this is S, this is S, this is S. Correct? Equilateral triangle. This is S, this is S. And you know that the perimeter is R. The entire length of the perimeter is R. Now, how do we find the area? Area must have, area of the triangle not so bad. Area rectangle, we at least must find AB, right? Correct? You must at least find AB. What is AB? I think it's not that bad. I take R minus away 4S because this is 1, 2, 3, 4. Then you are only left with AB and BE, which are the same, divide by 2. This is AB. Make sense? This is the same, this is also DE. Alright? Can? So once we have that, then I can write area. Area is area of the two equilateral triangle plus the rectangle. Two equilateral triangle is 2 times half AB sine C plus the rectangle is R minus 4S over 2 times S. Then you got answer. I don't want to write, lazy, you do on your own, okay? This is the more important line. Okay? From here to here is quite standard. Sine 60 is root 3 over 2. Alright? Sine 60 is root 3 over 2. And simplify. Okay. Question? All alright? Okay, let's carry on. Hence, find in terms of R the length BC such that the area of the hexagon is a maximum. Okay, what is that? Now, this one, this is A. I want to warn all of us, This, can I have attention? Thank you. You have S, you have R. These are letters. You must be very sure that this expression is only made up of one variable. That means if R and S are both variables, then you don't proceed to differentiate first. But in this case, because it says R is fixed, that means R is a constant. Then can. Because if R is a constant, this is just an expression in S, so you find dA ds. Done, finish. But had R not been a constant, and R is allowed to float, R is allowed to change, you tackle it differently. You have to make A as a subject of only one variable. Follow what I'm saying? Yes? Okay, so but this case is not difficult. I don't want to say too much. This is quite a simple problem now from now on. Okay, you just differentiate one time because R is a constant, it's not difficult. Maximum area dA ds must be 0, S is this. Tempting thing to do is to immediately substitute and then get, oh, I know what's the maximum area, done. Right? You will say this. You will say this. What do you think is missing if I write this like that? What is missing? Your first or second derivative test. You cannot confidently say that this is maximum before showing a first or second derivative test. Something is missing. In this case, look at the expression here, okay? It's actually quite easy to differentiate one more time. So I do first second derivative test. I do second derivative test. Why? Because it's quite easy to differentiate. In this case, I do this because it is easy to differentiate. Now, if I'm going to box up something and then if dA ds is not easy to differentiate, what would you have done? Then you do your first derivative test. I'm just going to quickly revise how to do the first derivative test. You would do this, you see. Now, if you want to prove that it's a maximum point, at this point, s equals to r over 8 minus 2 root 3, this point already is a stationary point. If you want to prove that it's a maximum, you actually want to prove that just smaller than this, your gradient is positive. A bit to the right, the gradient is negative. That's the approach of a first derivative test. So the presentation goes like this. You want to show the sign of dA ds. And you know at s equals to r over 8 minus 2 root 3, this one is 0. Correct? At s equals to this, you already found s equals to this, dA ds is 0. Here. Then you say, hey, how to calculate? Especially for this problem, because r, you don't know the value of r. And note, we are only interested in the sign. We're not interested in value. As long as I know it's positive, just positive whack. And it helps us that r is a positive number for sure. So what I would do is to substitute a number a bit smaller than, because I substitute in here. I realize that if I substitute in here r, here has r, everything is in terms of r, I can factorize the r out. You follow what I'm saying? One more time. If s is in terms of r, this s also in terms of r. Here got r, here got r. All the three terms has r, I can factorize the r out. So all I need to do is to substitute a number slightly smaller than 1 over 8 minus 2 root 3 into a calculator. Here. I will definitely get a value that is positive and negative here. Actually, that's all you need to present. Some of us will legit, I know. Don't think I don't know. Never do also substitute in. Just pray that you don't get caught. How to get caught, I also don't know. That means actually it's a minimum point. Let's say there are 2 points, then you better check. You follow what I'm saying, right? Okay? Okay, let's proceed with the next question, question 8. Question 8 has to do with binomial expansion. What time does this lesson end? 40, right? Okay, then I don't want to go through question 8 no time already. But I want to say, I want to do 11. See, ascending power, there are 2 ways to do it. Either you think, you factorize, you do 1, you factorize the kx out, and then you get 1 plus 1 over kx squared minus 1/3. Or you factorize the 1 over x out, and then you get 1 plus the kx squared. Now, you can do either of the two, right? Because you want to make use of Maclaurin's or rather your binomial expansion, it must be 1 plus something. You must make it 1 plus something. Now, there are 2 ways to do it. You can either factorize 1 over x or factorize kx. When I say either or, actually only one can get you the answer. Why? Because the question clearly specifies it must be ascending powers of x. You all go and think which one will get you ascending powers of x. Okay? Go and think, it's either one or two. Cannot be. One of it is right, one of it is wrong. Okay? Can. Let's do question 11, which is the killer one. Okay, 11 minutes. Okay, let's hurry up. Okay, come. Don't tell story already. Come, hurry up. Okay, 11. I'm going to go, there are some parts of the solution, they are very, very nitty-gritty, a lot of details. But I do want to focus on the big picture. That, what do you want to prove? BC is this whole long thing. Right? This whole long thing. And you are given all these angles. Can you imagine doing this in exam? Not as part of a revision chapter, okay? This revision chapter, you know, sure got to do with Maclaurin expansion. Can you imagine doing this in exam? Put yourself in this mode, exam mode, where you keep doing. First question is don't know what. Second question is complex number. Third question is curve sketching. Then after you come to this question, how do you actually start? First thing you should say is, now BC, you see this is a trigo question. Somehow BC must be expressed in a trigo form. Then how do you get to a polynomial form? Then that's why I say the big idea of Maclaurin's expansion must be there. Maclaurin's expansion is meant to convert an expression into a polynomial. So somehow you must trigger that thought or use Maclaurin's expansion. Focus? Ken? You know what I'm saying, right? So first, somehow it must be in terms of trigo. So we focus on a trigo, then after that you know somehow, subconsciously, you know you got a means of Maclaurin's expansion. So I want to say a few things. First, my thinking process is I know that BC is in terms of BD and DC. BD is easy because I have this angle, I have this length, I can do this. DC also simple, I have this angle, I have this length, I can. So I do that. That's my thinking process. That's how I think. After that, the solution, don't bother, very difficult, I cannot think, but never mind. But I'm sure you can, actually. Then, we start. We start by finding BD, because BD is easy. Right? Use the trigo tangent pi over 6 must be equals to h over BD. Correct? And tangent pi over 6 is what? Tangent pi over 6 is 1 over root 3. So you cross multiply, BD must be equals to h root 3. Wow, so easy, done. We tackle the BD, which is the easier one. Got it? Yeah. Now, the difficult one is DC. But we can still use tangent because tangent pi over 4 plus x must be equals to tangent pi over 4 plus x must be equals to h over DC. Which means DC is h over tangent pi over 4 plus x. Well, then you panic already. If you stop here, okay, I can forgive you, right? You stop here, most of us would have stopped here and say, okay, I cannot proceed anymore. But remember what I say. You are somehow to convert this into a polynomial, you must make use of Maclaurin's. But you cannot use Maclaurin's directly here. Why? Look at the question. The question says that x is sufficiently small for x cubed to be neglected. I cannot use Maclaurin's expansion here because if x is sufficiently small, pi over 4 plus x is not small. So cannot use. I say one more time, x is sufficiently small, but pi over 4 plus x is not sufficiently small. Cannot use small angle approximation now. The approach is to make it in terms of tangent x. But how? Only to memorize. We have our friend MA15. Our friend MA15 is here. Tangent A plus minus B. So, I can do this. So therefore, DC, I factorize the H out. Okay, let's look at this formula. It is tangent A plus tangent B over 1 minus tangent A tangent B, right? So I flip it out because it was in the denominator. So tangent 1 minus tangent A tangent B first in your numerator. So 1 minus tangent pi over 4 tangent x, and then tangent pi over 4 plus tangent x. Which actually is what? Tangent pi over 4 is what? Tangent pi over 4 is what? 1. Very easy. 1. Oh, sorry, I must say very H. 1 minus tangent x over 1 plus tangent x. Now we can do, because tangent x. Now x is small, x is small. So tangent x, recall from your notes above, you can have this. Now, can I emphasize this is not in formula list? Just now I told you, alright? This is not in formula list. So tangent x is x, see, for x cubed. This is not in formula list. So, you just replace tangent x with x, tangent x with x. Then you say, wrong, still cannot still stuck. Cannot get, because the final answer got no denominator one. See, 1 plus x. Wow. Then you apply your binomial. That means 1 plus x to the power of minus 1. You know what I'm saying, right? Done. But like I said, don't focus on nitty-gritty, but actually you got the idea. It's not difficult. Sorry. Okay? This one as this one. Use binomial with that.